Hello all, welcome to our project Bike Rental Count Prediction. So now in this project our main aim will be the prediction of bike rental count on a daily or a hourly basis based on different environmental and seasonal settings. We'll be doing all of these things with the help of machine learning algorithms and different automated machine learning libraries. So let's buckle up and see how we can do and build this project. So now first of all, let us understand our main topic, that is the bike rentals. Now bike rentals are basically the service providers which provide you the bikes in a daily or hourly basis. So now let's suppose you are going on a vacation with your friends. Let's suppose you are going on a Goa trip. You might want to rent a bike, right, to explore the cities. So there, that is where bike rentals come in. Bike rentals give you the bikes on the base bike give you bikes to move around the city, and they charge you for it. So now, as I said, that road trips would not be very exciting if there were no bike rental or car rental company. It is obvious, right? Okay, if you are going on a road trip with your family in a new city or anywhere else, you need a bike rental or car rental service. Because you can't go to your own vehicle everywhere, right? You are going to 1,000 kilometer away by airplane or a train. You can't take your vehicle with it, so you use bike rental or car rental to help in your case. So now there are hundreds of bike rental company all over the country which provides the service. Now the catch is they keep a count on the rentals they make on a daily basis. So now that this is our dependent variable which we need to predict, that is the count. So now how and why are we doing this? What is there is a need to keep the count or predict the counts? Suppose you are planning to open a rental company, you have a rental company and you want to expand your business to a new area or a new city. You might want to use this machine learning application which we'll be building, because with the help of this you can easily predict the this much count of bikes will be renting on a daily basis in this location. So that will be very helpful for you, right? So now this is basically a business model. This will be very beneficial for our bike company or rental company owner. Okay, so this is a very exciting, right? So now let's proceed. What we'll be doing, how we'll be doing all of this. So as I said earlier, our main aim will be to accomplish the following study, that is the prediction of bike rental count hourly or daily basis on the environmental and seasonal settings. Different environmental and seasonal settings are provided to us and the different attributes are given. We'll be predicting, okay, what is the count. So now let us discuss something about our data set. We have a bike sharing counts dataset aggregated on a daily basis. That is the daily basis, how much count is there. There was one more dataset, that is the hourly basis, but we don't actually require that because we don't want to see, okay, how much bikes are renting on an hourly basis, right? On a sum of scale, I want, okay, how much bikes will be there in a daily basis. Tell me the sum of sum to have a sum short completed summary. So now as given, there are 731 days of record. That means there are 731 rows in which the data of 731 days are given. 730, every count of each day is given. So now how we will be doing all this? We'll be using the machine learning libraries and the automated machine learning algorithms for prediction of the bike rental counts. So now I hope that you are all familiar with different machine learning libraries which we are used, different classification, regression, or the clustering algorithms like the k-means clustering, logistic regression, linear regression, XGBoost classifier, regressor, random forest. These are all different machine learning and ensemble techniques we all know, right? So now the new thing here is automated machine learning. So now let us understand a bit about it. Automated machine learning. Automated ML or automated machine learning enables developers with limited machine learning expertise to train high quality models specific to their business needs. So now as written, automated machine learning basically automize the model development part. If I am a domain expertise and I don't have much knowledge about machine learning and I don't want to install all the models and do the hyper tuning part and see all of that things, I can simply use a automated machine learning library that will do all of those works for you. That will automatically select the model, automatically build the model, hyper tune it, and predict me the results. I don't have to do a single thing instead of writing a some amount of code. We will be seeing that how it is different from machine learning, the automated machine learning codes, and how much easy it is in our upcoming sections. First, let us have a look about which automated machine learning library we will be using. So we will be using H2O AutoML. H2O AutoML is a very big open source library and quite popular. It is distributed in-memory machine learning platform with linear scalability. Now, H2O supports most widely used statistical and machine learning algorithms, including gradient boosting machines and generalized linear models, deep learning models, and many more. So as written, H2O AutoML has numerous amounts of model including linear model, regression model, all the sklearn models, clustering, classification models, everything is present inside H2O and many more techniques. I'll be demonstrating some of these techniques and providing you the website of H2O AutoML and telling you okay how you can explore this machine learning library in this project and another. So now moving on to a timeline of the project. So now the very first thing which we'll be doing which will be importing our data libraries, of course. Then we'll be doing data analysis and data cleaning part. So now in this part we'll be seeing our data, we'll be cleaning it and we'll be arranging it and extracting some information from it. Then in the next section we'll be doing the data pre-processing and feature engineering part. So now in the data pre-processing and feature engineering, we'll be handling missing values, handling categorical variables, doing label encoding or one-hot encoding, handling outliers, all of these different things. Basically, making our data ready for feeding our model. Then afterwards, we have prepared our data is ready. We'll be building a machine learning model with the different machine learning algorithms that we'll be seeing what algorithms will be used. We'll be predicting it. Then we'll see. We'll use H2 Automate and compare it with the all the predictions we made with ML and see that how these are different and how we can use automated machine learning to avoid all the model development phase. Okay, so now this will at the end of this project you will be able to do all of these things in this project and in the next project or any of your project of your choice. So let's begin. Hello all, welcome to our project Bike Rental Count Prediction using Machine Learning and H2O AutoML. So now as discussed in the previous section, that is the introduction section, I have told you that okay how what bike rental is and how are these important and how our count prediction is important for a bike rental company. So now this is all the background which is given that bike sharing systems are new generation of traditional bike rentals where whole process from membership rental and return back has been automatic. This is the basic background information which is given. Then this is something about the data set, that how from where I took my data set. That is I took my data set from the from this company. From this the data set is taken from here actually, and we it is said that we aggregated the data of 2 hourly and daily basis, then extracted and added the corresponding weather and seasonal information. Weather information was extracted from this. So this is basically telling that okay the providers, the dataset providers, how did they get this data, okay, from where website and how did they extracted their data. So now remember, whenever in a data science cycle you will not always have your data at your fingertips, right? You might have to extract your data from different websites, so you might be knowing web scraping also. It is a pretty good practice. So now this was all about the project, the background of the project and about the data set. So now the objective of the case is to prediction of bike rental count on daily basis based on different environmental and seasonal settings. So now moving on, this was the timeline which I discussed. This first will be importing libraries, data set, then data analysis and pre-processing, feature engineering, model building using ML, model building and prediction using H2O AutoM. Now the very first thing let's get started with is importing our libraries. We'll be importing NumPy, Pandas, Matplotlib, Seaborn and the different sklearn libraries. So now NumPy, Panda for processing, Matplotlib, Seaborn for visualization, sklearn model selection basically for all the data pre-processing techniques and all the other things. So now the very first thing is we have to load our data set. Okay, we have to load our data set. So now as we are working in a Google Colab environment, there is a certain procedure on how to load your data set. Now the very first thing you have to do is you have to import your file, import your CSV file which you want to work on into your selected Google Drive. You first have to upload that into your Google Drive. Then what you'll do, you'll just go here and the very first thing you are seeing that there is no Google Drive present. Okay, this is not my Google Drive. This is a sample data which is present inside the Colab environment, but there is no drive. So what I'll do, I'll mount my drive. I'll mount my drive data into this Colab environment. How I'll do that? I'll just click on this command mount drive and this command will appear. This command will appear. You just have to simply execute it. When you execute it, it will provide you a link. Basically, it will take you to your account section in which different accounts are there, and you just have to authorize that account. You have to sign into that account. You have to authorize the Google Colab to give me the permission. Then after that, it will give you authorization link. You have to copy it. You have to copy it. You just paste it here. Enter your authorization code. You press enter. Then what will do, this whole process will mount your drive into your collab environment. As you can see, mounted at content drive. So this was a brief a short process on how you cannot import your data directly in a collab environment. If you are working on a Jupyter environment, it can be imported directly, but in a collab environment you have to follow these steps. So now what you'll do, as you can see, my drive is mounted. First drive was not there, my drive is mounted. Then I'll go to my drive, and these are all the files present in my drive folder. So now my file name is day.csv. I'll find it here. As you can see, this is my file name. I'll copy the path. I'll copy the path of this, then I'll just paste it here. Okay, pd, I'll use the panda command to read my file, the usually like we do. Then I'll paste the command here. Okay, then I'll just click enter, and my command or my data is imported. If I want to see my data, this is my data set. Okay, as you know, how easy was this to import our data into a Google Colab environment. So now this was the introduction part on how to import the libraries and data set in the Google Colab environment. The next section we'll be doing the data analysis and pre-processing part, and all the other things in the further sections. Hello all. Welcome to our next section of the project, that is the data analysis and data cleaning section. So now before we proceed, let us have a look at our data and understand, okay, what are the different columns present in our data. So now as you can see, this is our data set which is having around 760 to 770 rows, as I have told you in the introduction part. But what do these columns simplify? What do these columns signify? Let us understand our data. The instant is the record index. Basically, it is the normal index which is used. It is basically the same. It is same as this. The only difference, it is starting from 0 and it is starting from 1. Day is basically the date, and the season is basically the seasons. Okay, one is for spring, second is for summer, third is for fall, and fourth is for winter. The very good thing is that the label encoding is already done in this data, so we don't have to do all of the label encoding things. Similarly, for year, 0 is for 2011, 1 is for 2012. Month are different from 1 to 12, as the order. Hour is from 0 to 23, like the 24-hour format. Holiday is whether day is holiday or not. Okay, whether day is holiday or not. As you can see, it is given extracted from this website. They have extracted from this website. Then weekday, day of the week, which day is the Monday is for 1, Tuesday is for 2, like that. Okay, working day is neither weekend or holiday is 1, otherwise 0. That means if it is neither a weekday nor a holiday, it is 1, or else it is a 0. That means it is a holiday, 0. And it's 1, it's a working day. In weather set, the different categories are there. 1, 2, 3, 4. 1 is for clear, fluke out. Second is for mist, cloudy. Third is for light snow, light rain. Fourth is for heavy rain, ice pellets. Basically, this will play a very important role in telling her how counts is distributed. Now, temperature, that is the normalized temperature. The all the data is pre-processed. The label encoding is done. The data pre-processing is already done. Okay. So now that is a very good thing. Otherwise, we have to do all of these things. So thank you for the data providers for that. So now air temperature is normalized feeling temperature in Celsius. Okay, the values are divided to 50, that is the max. Now hue is the normalized humidity, the 100 is the maximum. Wind speed is normalized wind speed, 67 is the maximum. Casual is the count of casual users, registered is the count of registered users. Count is the total count of rental bikes including casual and registered. So this is what we require. Basically, casual and registered are not so important, because of the thing that that count is their total only. Okay, so it is not that important. So now the next thing we have to do is we'll be doing some data analysis. So let us see that what is the shape of our data. As you can see, I told you there are 731 rows, that is the 731 days data, and 16 columns, which we discussed. And all the data types we are given. So here all the data types is basically the integer data. Okay, integer and some of our float data. So now for a better understanding, let us rename these models. Okay, rename this data. Instant is given for recreate rec ID, basically the ID. Date days converted to date time, year to month, and weather condition, so that we can understand it better. Okay, we can understand it better. So have a look at that. The now it is basically a person who don't know anything can understand it basically by reading only. Okay. So now the second thing what we have to do, we have to change the data types. Okay. Now, as we all know, these are all are integers, right? But these are all of some part of category. This is that we have to convert this into a date time data, and another all we have to convert into categorical data or categorical data types, because these all are categorical data. Okay, we know that these all are categories, label encoded categories. So now when we'll see the data types, we can see that okay, all of these are converted into category, and our float, all the different float are there, and the integer which were given. So the categorical variables have converted into categorical type, and date time is converted into date time or data type. So now we can describe our data. Basically, it will give you all the count, standard deviation, mean for all the different numerical variables. That means there are total 731 count, and the maximum and the standard deviation is this, mean of the count is this, wind speed is the mean is this, and the maximum is zero point 0.5. Basically, it is normalized, so we don't have much information about it, right? It is normalized, so the original dates are all already gone. So now let us see that if they're having any missing values. Now another good thing that our data does not have any of the missing values. Okay, so now that is a very good thing. We don't need to do any much of the data pre-processing technique in this. Now let us do some data analysis, right? Let us see how different months and season affect the rental counts. Okay, how rental counts is affected for different months and different seasons. So now in the very first plot, what is this? This is basically a bar plot of the different months. As you said, na, okay, there are different months on the base of Monday, oh, January, February to December 1 to 12, and this represent the different seasons. And why these are different? Because as you can see, the highest count is between the month of 6, that is July, June, July, August, September. These are basically the 4 to 5 months are the main which are having the counts. Okay, these are having the main counts. So now why these are the data is different, because the season depends on the month, right? The one is the another season, the base that is basically the winter season. Of course, that is the summer season, rainy season, and the different seasons are there. If you want to see what one stands for, we can also see that the one stands for spring season. Sorry, season. Four stand for winter season. So now this is how our months data is distributed. Now in the second column, what is there? It is basically dependent on month. Okay, how the weekday, in which month the different week, in which weekday the rental count is more. Now the month, already we have seen that which month has the maximum number of count, but according to the distribution of days, we see that basically the weekend days are having the maximum. Okay, the 5 to 6 in many of the months are having the maximum count, and also the weekdays are also having approximately the same. So the people might take the bike rentals for going to their office, right? In some months, like say in the seventh month, you see that as soon as the weekend approaches, the count is decreasing, and in the some month it is increasing. Like in the January, February, March month, it is increasing as the weekdays approaching. So now these are the basic informations. Now how I did that, I simply plotted a bar graph on that bar plot for the both, and I simply gave all the different columns. So now in the second section, what we'll see that okay, there is a certain bar plot which we will see, which will tell us that okay, what is the yearly distribution of counts. Okay, the yearly distribution of count, the one stands for our as you can see, one stands for basically our 2012 year. Okay, one is our 2012 and zero is our 2011 year. I should have written that here. So now one stands for our 2012, which means that 2012 to 2012 year is having the high count than as compared to the previous year. So now similarly, when seeing and for the distribution of counts based on the different seasons and the year, I have plotted a Boolean plot which will be telling us okay how these are distributed. But Boolean plot is basically the same. We are not getting much information from it. So let's plot a certain bar plot for the same data. So now from this we see that in the year 2011, the first season, that is spring season, had the least, and similarly in the 2012 also spring season has the least count, whereas all the three seasons were approximately same, whereas having the winter season, this is basically spring season, sorry, spring season having the highest, the third season. Basically, obviously the spring season people like to go out, right? People like to rent bikes and they like to go and roam. So that's why the spring season highest bike rental. So now in the same day, we can say that what our count is done on the working day. Okay, if the working day is there, the count is more or less. Basically, it is the same for the both. There is not much difference. As usual, the first season, spring season is the least count, and the third season is the highest count. So now the another thing what which we can see is that we can see how the weather conditions are termed. So now the first condition was very favorable sunny weather. So as you can see the highest count is that, and third was not a very favorable condition, heavy snow and heavy weather condition. That's why the count is pretty low. So now these are the basic things which we found out that okay how our count is distributing, and the recruiter or the company can find out, okay, can have an idea if we'll show him into a presentation, he can have an idea okay what are the different parameters which is affecting my count and what are the other things which I have to keep in mind. So now this was all the data analysis, and there are some more things left in the data cleaning part, that is the outline analysis, seeing the normal regression, correlation matrix, and all the other things which we'll be doing in this next part of this video. Hello all, welcome to the next section of the project. Basically, it is the next part of our data analysis and cleaning section. So now the what things left are our outlier analysis. Basically, we'll see that if our data is having any outlier, not for that, we'll be using the box plot and we'll be giving the data, which is the data total counts. We'll be seeing that if it is having any outlier or not. In the box plot, the outliers are present in the form of black dots above these, okay, above these. That means how we can see that okay these are the outliers. So now as you can see in the total count there are basically not much, no outliers, okay, there are no outliers present in the total count section. Let us see for the same for our numerical variables what are the different outliers are present or not. Now as you can see temperature has no outliers, but the wind speed and humidity have some outliers, that is two outliers are there, and around 7 to 8 outliers are there. So now as I said that outliers is represented by DAO. What are outliers? Basically outliers are the data points or data entry which are generally out of the group of the data, out of the range of the data, okay, the out of the 100th percentile and 0th percentile of the data. These are some positive outliers, मतलब greater than 100% of the data. These are some negative outliers, that is less than the 0% of the data. So now, but as we see that they are less outliers, so we don't need to worry about them. If you want, you can do some outlier analysis also. There are different methods of handling outliers, which are of course a different topic. That is a huge one of how to handle outliers. But you can obviously handle the outliers in that way. I am not doing that because there are not much outliers in that. It will not be of great effect. So now in the next section, I'll be seeing that okay, if my continuous variable is normally distributed or not. For that, I'll be using a QQ plot. So now what is a QQ plot? QQ plot basically tells me that it is a combination of a probability plot and a histogram plot. It will tell me that okay if my data is normally distributed or not. As you can see, this is a bar graph, and which is my total count variable, and this is my probability plot. That is the probability plot. It is if my all these are my scattered points, right? These are my scattered points, and if these scattered points lies on my line, that means my data is normally distributed. As you can see from the bar graph also, a bell curve is formed. That means my data is normally distributed, which is a good sign. Okay, my data needs to be normally distributed in order for my model to perform better. So now my data is normally distributed. So now I can see for all other different numerical variables, like the one we have is, let's say the one we have is uh, uh, let us take temperature, right? Let us take temperature. If I have what I have done, I have plotted a function for plotting a QQ plot. I have then defined a function that says plot curve. It will say, okay, plot a figure, then plot two subplots. In that first plot, plot a histogram, and in the second plot, plot a probability plot with the distribution normal function. So now if I'll say it is temperature, then it will give me that plot. Okay, as you can see, this is my temperature variable, and as you can see, it is also normally distributed, a little deviated from the line, but it is okay. Okay, it is okay. It is also normally distributed. So like this we can see all the different all numerical variables. If you want to see my df dot head here only, we can see these are, if I want to see my how my humidity is distributed, I'll see how my humidity is distributed. So this, as you can see, my humidity is distributed perfectly on the line. This means that okay, my data is very good and distributed properly. So now this is basically a function. What I did, I plotted a function so that I don't need to do many of the things, write the same code for the different times. Okay, so this is basically a simple Python logic code, how you can make your coding easier. Okay, I plotted a function to plot a QQ plot. I can give any numerical then a continuous variable here. Okay, moving on, we can also plot a correlation matrix. Correlation matrix is basically a heat map which will tell us the graphically that how our features are correlated. For that, we'll be storing first the correlation in another data frame for all the continuous variables or numerical variables. We'll be finding out the correlation. We'll be telling that okay, make a correlation map, make a heat map and take the data from this correlation. Now this is my beautiful correlation plot in which all the different continuous variables are given, and it is given that okay, how my data is correlated. If it is negative, then it is dark color. If it is positively correlated, it is light color. Okay, so now this is how my data is correlated. This is a simple code in which it is taking all the correlation values, then it is telling them as array, np.array. It will just telling it making them into indices. Then it will saying that okay, plot make a subplot, plot a heat map on that, and n naught is equal to true. Basically n naught is a function which will help me in overwriting the data. So that is a function. So this is my preferred heat map. So now this was all the data analysis and cleaning techniques. The next section what is remaining is the data pre-processing and the standardization and one-hot encoding. Basically standardization is done already in a data set, so we just need to perform the one-hot encoding and split our data for our model development process. We'll be doing that in the next section. Hello all, welcome to the next section of the project, that is the data pre-processing part. So now in this section we'll be doing some pre-processing techniques to make our data ready for our model development process. So now what we'll be doing, let us first have a look at our data, right? After all the things we have done, let us have a look at our data. So now this is our data. So okay, so now what we'll be doing, we'll be first splitting our data into categorical and numerical variables. So now you can do it by using for loop, but clearly it has small data and it is clearly visible what are the different categorical variables and different numerical variables. I have written them with my own, that categorical variables are season, holiday, working day, weather conditions and year, all of these things. And the numerical variables are temp, wind speed, humidity, month and weekday. So now what I'll be doing on the categorical variables also, I'll be doing one hot encoding. So now one hot encoding is that the label encoding is already done. Okay, I'll be doing some one hot encoding in that it will be creating dummies. Okay, what one hot encoding does, it will be creating dummies. I'll be showing you that. First let me execute it and then I'll show you okay how it is looking. It is saying X is not defined. Okay, let me first. Oh sorry, I have to pass my data, that is my df. Okay, I have not executed this also. Now it should work. Okay, so now my data is ready. So now what it did? Okay, so as I said you earlier that there are different variables, right? There are different categories in the season. So now what I did in one encoding, I created dummies. I created dummy columns. For example, in the season there were four categories, right? It's 1, 2, 3, and 4. What it did, it created four different columns. For in that, in which section that column season value was true, it gave me a 1, and the rest all was 0. For example, in the second column the season is first, that is why the value is 1, and rest of all is 0. Similarly, if the holiday is 0, that it is 0 to it is 1. Similarly, rest of all are 0. If it is a working day, then it is a 1. If it is not, it is a 0. Basically, the additional columns are created in order to make our model more understandable. Okay, I created it and gave it a name encoded head DL. So now what I'll be doing, I'll be removing this date time. We don't require this date time, right? It is of no use. So now let us see our encoded DF, that is our final DF. So this is our final DF in which all the different things are present. That is the ID, month, weekday. We have already extracted the weekday and the month from date time. Okay, all the weekday temp. Sorry, weekday was already present. We didn't require that from the date time. So we dropped the date time variable and all the other things in one hot encoded dummy variables. What we'll be doing now, we'll be splitting our data. We'll be splitting our data into a dependent and independent variables. Independent variables are all these variables from rec id to all our encoded variables. Okay, and the dependent variables is a total count. Hello all, welcome to the next section of the data pre-processing technique. Now in the previous section what we were doing, we were splitting our data. So now we have done all the one hot encoding. Now it was time for splitting our data. So now the problem was that in an encoded DF, our total count is here. Okay, our total count is present here, and this is our dependent variable, right? So this is our dependent variable. We have to split this thing from all my data. These are all my independent variables. So now the one thing what we can do is we can split it by defining the column row position, right? But it can be very complex. We can just what we will do, we'll just simply remove the last column from it. Then we will select all the column, that is a dependent variable, and the last independent variable, and the last column is a dependent variable. For that we'll just rearrange our columns. We'll rearrange our columns. For that what I'll do, I'll take all the columns which are present, that is the all the columns. I'll copy it and I'll just say okay, I'll copy that and I'll say rearrange. I'll take total count from here and put total count in the last. Then I'll say encoded df is equals to show me in this manner. Then my encoded df is correct. Then if I'll see my encoded df, if I'll see my encoded DF, my total count is present at the last. Okay, my total count is present at the last. Now I can easily split my data. I can easily split my data. The first I'll be taking all the independent variables. That is the all these variable and the dependent variable, which is the last row. Okay, as you can see, this is my last row. Now if I'll be seeing my x, if I'll be seeing my x, these are all my independent variables. Okay, all the different variables and all the encoded one hot encoded variables. Now if I want to see my y, that is my count or the dependent variable, this is my count. Okay, so now my data is splitted. Now what the only thing what I have to do is split my data. I'll be using the train test split technique, which is the most common of all. I'll be passing my x and y. I'll be saying that test size is 0.3, which means that it will be splitting my data with a 70% test size and 70% train size and 30% test size. Now if I want to see my x train, this is my x train. Now if I want to see my shape of my x train, how many records are taken for my x train data, that is the 70%, that is the 512 rows. Now if I want to see my x test, I'll see x test. Now this is the shape, that is the 30%, that is the 220 rows, that is the x test. Now the similarly I can do for y train 511 are taken, and similarly y test will be around the same, the 200 something, 220 something. So now 220 my y columns are taken. So now my data is perfectly ready. My train and test data is ready. I have splitted my data. the one hot I have done one hot encoding on this, the label encoding, and my data was already done with the label encoding and the standard scaling part. So my data was completely okay. All I did was to did some data analysis and split it my data. So now my data is completely ready for building our model. So now in the next section, we'll be building our model with the help of different machine learning algorithms, which we'll be seeing. Then we'll be demonstrating that, okay, how we can do all of this using the automated machine learning. That is the H2O AutoML library. Hello all, welcome to our next section of the project. That is the second last section, which is the model building. Now in this section, we'll be using different machine learning algorithms to build our model with the data which we have just process. So now the first model, we'll be using the following model. First is the linear regression and second is the random forest regression. I have not used much model or done any more hypertuning in these because our main aim is to see that how we can do all of these using the automated machine learning. So now these are only for demonstration and telling you that, okay, how are the model building is done using the ML techniques. So now the first model which I have taken is the linear regression. Linear regression, you all know y is equals to mx plus b. That is the main equation of the linear regression. There are different regression with linear, the multiple regression, polynomial regression, lasso regression, ridge regression. You can use any of these. I've used linear regression for the most simplicity. So now I'll be importing linear regression from sklearn.linear model. All the regression models are imported from this library only. Then I'll define my model. Then I'll fit my model with the X train and Y train data. Then I'll just predict it and store that predictions in this model. Now if I want to see what is my accuracy of my model, I can see that accuracy of my model is this. These are my model coefficients. My model intercept value is this. So now what I can do, I can also see what is my read root mean square and my mean square absolute error. Okay, this is my root mean square and mean absolute error. These are the simple techniques which we see that, okay, by saying that, okay, how our data is or our model is performed. This is my y test minus y prediction. Okay, as you can see, my the linear model is not performed that much good because what I did is y test minus y prediction. In that, I am simply subtracting my original value to my predicted value. If my value is around 0, but this is quite distributed, right? My 0 is also quite high, around 40, but my total minus 2, there's a difference of minus 2 to a difference of 4 in my value. Okay, so now which means that the sum of the values are not correctly predicted, and these, if count, these are large in number when compared to 0. My minus 2, minus 1, 1, 2, 3, 4 are large in number. That is the wrongly predicted. That means a model is not that great correctly predicted. Of course, this is a simple linear regression model, so you cannot expect more from it. Now the next model which I'll be using are random forest regressor model. So now I hope that you are all familiar with the decision tree, right? How decision trees are, what decision tree are. So now random forest is basically an ensemble technique which uses different decision trees. It creates many different number of decision trees, and then it try to see, okay, which model, which decision tree is best on the base of different parameters like impurity, gain, and other split, and all of the different things. Okay, so we can import this model with under the sklearn ensemble library, as it is an ensemble model, so it is imported from here. I can define my model. I am defining my estimator say 200. I can also do the hyperparameter tuning. Then I can see, okay, which parameter use is best, or which are the number of splits. Splits are best, or all of these things with the help of grid search CV or randomized search CV. You can do that at the form of an assignment, but I have not done that here. Now, if I will saying that score, as you can see, my accuracy of model is quite good. 99.9% is my accuracy with the random forest regressor model with the trained data. Now, if I predict with the test data, now if I want to see my what is my mean root mean square error, mean absolute error, so these are my values of that. Now if I want to see the same, if I want to see the distribution plot for it also, I can also see for it. I'll just say, okay, how in what I have stored my variable, it is rf dot predict. So I'll just write rf slash predict. I'll plot a distribution plot, as you can see. So now this model is performed very good in the form, and because of that, as you can see, the zero is in the maximum abundance, and very left or right skewed is very less, as the zero and the less error is in the maximum. That means our model is correct, predicted very good. This is how a random forest model is predicted. You can also hypertune it. You can use also different regression models like the XGBoost regression model. I am sure it is also a bagging or boosting technique. It is a boosting technique. Basically, it is also perform better in the regression model. The XGBoost regression model and all different regression models are also present. You can use those models and see, okay, what is the different accuracy. You can use grid search CV and randomized search CV to hypertune this model. These are the things which we have to do if we want to create a perfect model with the machine learning techniques. But now we have to see how we can do this. I have just simply showed you how you can use machine learning to predict, right? Now in the next section we'll be seeing how we can use the automated machine learning to do all of these things simply with a click. So this is our main purpose. So we'll be seeing that in the next section. Hello all, welcome to the last section of this project, that is the automated machine learning section. So now in this section we'll be seeing that how we can use automated machine learning to do all the things which we have done earlier. We'll be taking the data from the scratch and we'll be putting it into our model and we'll be predicting the results. So now it will be very interesting. So now, as I have said earlier, that I have given the introduction that what automated ML is. AutoML basically does all the model development part for you. And in this section, we'll be using the H2O AutoML. H2O AutoML is a fully open source distributed in-memory machine learning platform. It uses all the different popular models like the including gradient boosted models, generalized linear models, deep learning models. We saw in the previous section that random forest model was the best for us in the two model which we used. Now we'll see here, it will give us a list of models which are performing best. We'll see that further. But the very first thing what we have to do, we have to install our H2O. For that, what you have to do, if you are using your Google Colab environment or Jupyter environment, you want to install it in your notebook only, you can simply type these commands. Before installing H2O, you have to install these commands. Okay, you have to install these libraries, that is the request, tabulate, colorama, the future. You have to install these libraries. You can simply install it using these commands. So now you can also install it in your command prompt. I've already installed it, that's why it is saying requirement already satisfied. So now in the next section, I have said that okay pip install H2O because I've installed these libraries. Now it is installing the H2O library. So now what, make sure when you install it for the first time, restart your runtime. Otherwise it will not run. I have already installed, that is why it is not telling me. If you have installed a new library, always restart your runtime, then only it will read your library. Otherwise it will not read, it will continue reading your previous libraries present. So now what we'll be doing, we'll be importing H2O from H2O AutoML. We'll be importing H2O AutoML. Then we'll be saying H2O.init. Okay, write this. This is basically this is basically providing us a server, and it is making sure that okay, no prior instance is running. Okay, so now as you can see, this is our server. The H2O HTML is running on this server. So now init command makes sure that previously any new H2O service is not running, which will create problem in the model building section. Okay. So now what we have to do, these are all the different information of the XGBoost model, the extension, internal security, all these things. So now we'll be loading our data. The same process is the same process which we did in the ML section. We'll just import file, we copy the path and paste it here. Only difference is we use h2o.import file and not panda. Okay, though it is imported the file, this is our data. Okay, so now in this we'll first split our data. Okay, we'll first split our data into train and test, and we'll be taking the ratio is pointed. That means 20% for test data, 80% for train data. DF train is split in this, DF in this, and DF test the 0.2 ratio. Okay, then we'll see our DF train. This is DF train, and this the DF test also, it is the same, the 0.2 ratio split it. Then we'll split it into a dependent and independent variable. We'll see that okay, my y is count, that is the CNT count, which is my total count, that is my dependent variable, and all of the df dot columns is my independent variable. In that I remove the y, that is my independent variable. Also I remove the casual and registered, because count is the total sum of casual and registered, right? So we don't require these. So now x and y are available. I've defined my columns. I've defined my columns of my independent and dependent variable. I've splitted my data. Now what I'll do, I'll execute my H2O. I'll define my model. How I'll do that? I'll just simply say H2O AutoML. I'll define the maximum runtime. You can define any of the runtime you want. I'll be telling, okay, use maximum max model 10, use maximum C 10, verbosity number of words use 2. You can go to their website, see their documentation, and you can see that, okay, how much time. You can also remove this factor. Okay, now if you want to see, see what are the different attributes present, so also you can see from their website, and you can see what there are many different things you can write here. Okay, I have not included them here, but there are many different things. Okay, so now this is how I define my model. You can see their website. Now I'll just simply train my model. I'll say aml.train. I have given my columns and I'm taking my data from my df train. Okay, I'm taking my data df train, and I have told you that my dependent variables are stored in y column, independent variables are stored in x column. As you can see, it has trained different models, tagged in symbol model. All the different models are trained. It has given me all the information on those different models, RAE, MSE, R square, all of these things. Then I can see the leaderboard. What is my leaderboard? Now I can by aml.leaderboard. Now as you can see that the stacked ensemble is my best performing model with this RMSE, MSE, MAE, then followed by other GBM models and all the other stacked ensemble models. What I'll do, I'll just take all of these IDs in order to see, in order to extract my information. These are all my model names which I have taken, and which I have names I have taken. Then I'll say, okay, I'll say that, okay, tell me my leaderboard performance on my test data. Okay, AMD AML dot leader, which means that leader is the best performing model. I'm telling, tell me my model performance on my test data. So this is my model performance. This is the R square 89% on my test data. This is my RAC RMSE scores. Now what I'm saying that, okay, give me that model in which, as I said that my main model is tagged ensemble, right? So I'm telling it, okay, give me all those models in which tagged ensemble is present. It will be telling me all those models in which tagged ensemble word is present, and it will be getting that model. Okay, as you can see, it has getted two models, the top two models which are there. It has showed me all those information. Then I'll say, I can also take all my parameters which are present. I have stored my model, the very first performing model, in my output. Then I'll say output dot parameters. As you can see, all my different parameters are displayed. Okay, what were the parameters which were used? Then I can also see that I can see my leaderboard. Okay, I can see my leader model which we perform, that it was tagged ensemble model. So all the different information is given for my leader model. Then I'll just simply say, okay, with the leader model predict, with my leader model predict my results. It is as simple as that. You don't have to do anything. What you did, you just simply splitted your data, defined your independent and dependent columns. You checked, okay, which model performed the best. You stored it. You didn't need to store it. You just need to sorry, you just need to pass the command dot leader, aml.leader.predict, and give the data. It will automatically predict. As you can see, predictions are in front of you. So it was as simple as that. Okay, it was as simple as that. All these predictions are there. So now as you see the difference, okay, how they use the machine learning algorithm, we only did the two models. Okay, we only compared the two models. For that we have to write so much amount of code, even though without hyper tuning. Okay, and with the 3 lines of code we have done that, the whole process in the H2O AutoML. With these we have also given all the R square and all the different things. Okay, the R square is 97%, right? The 97% of R square is there, and all of the different things are there. So it is pretty good, right? So there are many different number of things which you can do, which H2O AutoML. You can visit their website. This notebook is provided to you along with the data. You can check it out. You can build this project and all the other projects with different data with the help of H2O AutoML and all the other different machine learning, automated machine learning libraries that are present out there. Thank you.